Now we're going to move on to configuring queuing areas. All right, when configuring queuing areas, there are a few key tips that we have for you. The objects required are going to be an overarching pedestrian static route. So like we looked at before, we have this static route that's going from the entry to the general platform space. We need areas designated as queuing areas with dwell times on them. And then we need partial routes configured as service point selection routes. Some key tips here are when you're talking about the static route, there are two different ways that you can model it. You can span it from the entry all the way to each of the overall destinations. So if we imagine this like an airport terminal, we go from the curbside all the way to the different concourses with intermediate points at each of the different zones. The alternative is that you could just have a static route that spans each of the zones. It just depends on how you want to model it and what kind of data you have. Typically, the first option is preferred just because, or this upper option is preferred just because you have to code in fewer objects and do less repeating of information. The key here is that when you define the queuing areas, you place the position of the queue where you want the head of the queue to be. So you'll drop in a queuing area on top of the larger floor plan, and you'll define it as a queuing area. Now, what we'd recommend is that you switch over to wireframe mode because this will show a little arrow on the queuing area, which will show the direction of flow of the queue. And so you should be pointing that arrow in the direction that you want the queue to be stacking up. Pedestrians will always line up starting at the head of that arrow. So if the arrow is sometimes facing in the opposite direction, the queue will kind of snake around and get all jumbled up. The other thing that we recommend is, and this is before placing the partial routes, is that you place a queue selection point that is more refined than the larger floor space. You can put these intermediate points for the static route on the larger floor space, but by having this queue selection point area, you can kind of control, you can move that area around and control specifically where pedestrians go to start queuing up. And so they're not just kind of wandering all over the place and then deciding to go to a queue. Next, after setting up your queuing areas and your queue selection area, and then placing the static route, make sure that your static route has intermediate points on that queue selection point. So you see the dark blue dots around number 4. So you'd move those off of the general security area in this case and move it onto the queue selection point. Once you've done that, now you can place a partial route on that queue selection point. So by placing a partial route on that point, you're creating a new decision for this activity. And I like to think of partial routes as intermediate activities that you can do, whereas the static route is your overall destination route. So you'll place that red dot on the queue selection point, and then you will flag that partial route as a service point selection route choice method. And then we'll circle around to the route choice parameters here in a little bit, but as a quick reference, you use the number 0 for bank teller type queues where people are queuing up in one general queue and then dispersing one at a time to each of the stations. Or you can use 999 for checkout stand, similar to what you might see in a grocery store or something like that, where people approach the general queuing area and then just immediately disperse to all of the different queues more or less evenly. And then if you're using numbers in between 0 and 999, that's controlling how long the queues are at each one of those stations. So if you think of something like airport security, you have the long serpentine queue where people are generally waiting, and then there's 5 to 10 people at each of the stations, taking their shoes off or putting their luggage on the trays. Then you'll place destinations on the general floor area equal to the number of queues, and then you'll place you'll place intermediate points on the head of the queue. This will make it so that people travel through that queuing area and then dwell for a certain amount of time. So our example that we're going to get into for this one is, again, Farragut West. So here is the queuing mezzanine that we have for Farragut West. We've turned off the platform level and the street level, so it's a little bit easier to see. But here, what we have is we have passengers arriving from the west. And as they arrive, they are routed onto these two queue selection areas. Now, again, we could have routed them onto the mezzanine, but what we did was we created these turnstile selection areas at a slight angle because this kind of helps people orient themselves in preparation for the queues if the queues get a little too long. Similarly, they're two separate ones, so that way we can navigate eastbound and westbound passengers independently of each other. And then we have, since this is an AM model, most of the turnstiles are set to outbound because there's a heavier flow coming outbound. And so here we have two intermediate queue areas that are leading to the turnstiles. This is specifically for controlling the shape of the queue. So they'll make a decision here, and if we look at this route, we have it set as a service point selection for 99999. And so what this will mean is that pedestrians will arrive on this area and then immediately choose between these two queues, and they'll look and stack up at these queues for as long as they can. Then once they arrive at these two queuing areas, then we have shorter queues, again, service point selections for 3 people controlling, so that only 3 people are queuing up at the turnstiles themselves. And this is because what we witnessed was a lower density close to this turnstiles than there were upstream. And so we wanted to model that by having more dense queues past these points, past this bend in the wall, and then less dense queues down here. So there's only 3 passengers waiting between these 2 points. And then on this area specifically is where we have the time distribution that we've defined for this area. And so pedestrians will be arriving through here, and then this is their destination, where they will choose between going to the orange gate or the orange platform or the blue platform later on down in the model. So I'm going to let some pedestrians arrive in the network. Fast forward a little bit. So here we see pedestrians queuing up down below. They make the decision, they pick between the queue, and you notice that they're not stopping if there's no pedestrians up in front of them. And then we're using obstacles to kind of corral people. And then in the opposite direction, these are just free flowing, so we didn't put any queues or anything like that.